everyone. Antibody identification. That's going to be the lecture we're going to cover today. This lecture is going to be a little different than other lectures in that I can't show the PowerPoint like I would usually show because I'm going to be bouncing back and forth between the PowerPoint and the actual antibody ID. So we're going to see it in this form. So off to the left, yeah, you're going to see, the future slides and whatever, but we're going to get through it. Okay. It's just going to look a little different than normal. So at this point, we are going to start talking about antibody identification. I think I have to do this. I might have to do it that way. There we go. So when do we worry about doing antibody identification? We have to identify an antibody whenever a screening cell is positive at 37 or in anti-human globulin phase. So pretty much if a screen says, oh, there's something there, we have to find out what it is. That's the whole point of a screen, is to look at patient plasma and see what we're looking at and look at it to see, what if there's any antibodies there that could cause problems with potential cells from another person. So the antibody screen is positive. We have to do an antibody ID. We have to find out what it is. It could potentially be clinically significant. We may have to transfuse antigen negative blood, meaning we have to make sure that if somebody has an antibody that we don't give them more antigen, because that's going to create more antibody and more problem. Or in cases of HDFN, we may need to monitor the fetus because we might need to watch the fetus to make sure that there's not more antibody going up that's going to cross over and hurt the baby. We do not need to identify antibodies that are present at immediate spin only, meaning we do this in a tube, we look at it, and then it goes away with 37 or AHG. Those are going to be clinically insignificant. They will not affect your transfusion practice, and they will not cause HDFN because those are going to be our IgMs. They're going to be nuisance antibodies, so we do not have to identify those. So in this situation, we have a positive immediate spin reaction right here, but it goes away at 37 in AHG and our check cells work. Remember, we always have to do those check cells anytime we do an AHG, and those check cells have to be positive, so they all work. At this point, it's a reaction only at immediate spin, so it's clinically insignificant cold. It goes away, no reason to identify. Now, in this situation, it's negative at immediate spin, and in this situation, we use a 37. Now, remember, we don't always do a 37. It depends on what type of enhancements you're using, but it is positive at AHG. And then screen 3, that should be 3. Screen 3 that is negative, check cells here. They worked, so it's a valid test. We have a positive. Now we have to identify. We have a positive in the AHG phase, so we have to identify it. This could potentially be a clinically significant IgG antibody, and we have to find out what it is. So we have to identify specificity. So when we're looking at these antibody ID panels, you have 11 cells of an known antigen, and then a 12 spot is for an auto control. So you can see here they're numbered with numbers versus Roman numerals. We talked about that when we talked about antibody screens. So I have 11 screen cells or 11 panel cells, and then the 12 spot is going to be an auto control where you'll put the patient cells and the patient antibody. So that 12 spots fills the inside of the serofuge. As it fills the inside of the serofuge, it balances all out. It's perfect. Now there are panels out there that are 16 cells, and there's different ones out there, but 12 is the 11 panel cells are usually the ones we go to first. We have to test the panel in the same phases you saw positive in the results in the screening cells. So what that means is in this stage, I don't have to do an immediate spin or 37. I only have to do the AHG phase. So you will set it up and incubate it right away. So this is a copy of an antigen panel antigram, and each of these, so cell number 1, actually you can see has this donor number. So this person is number 306017. Once every couple months, you'll see that same number rotate through. They pay you, you go in, you donate a lot of blood, they do all the testing, and they wash it up, put it in 3% in bottles, and they sell it to the labs. So we know that this patient, every time they come in, we know that they have any of these positives are antigens that they have. So this patient has D, big C. It does not have big E or little c, but it does have little e. So any of these positives, it tells us it has those antigens. The slashes mean not tested. Some panels, it actually says NT. Those are super low frequencies that oftentimes are not tested. Special antigen typing over here. You can see this patient number 8 has HLA antigen. Sometimes there are different things that are going to be over here. Sometimes it might be right. Other ones we'll see. Now, when you're looking, one thing you'll want to know is when we do crosses, whether it's a homozygous or heterozygous is going to make a difference. So we can always tell by looking here, big C and little c, that's big C is going to be homozygous because there is no little c. So that's going to be a homozygous. Versus, let me find one here. Here we go. Big C is positive here and it's positive there. So those are heterozygous big Cs. Now with D, how do we tell? We're going to look over here. So you can see here we have an R naught little r. That means it has a big D, but the other one is going to be a little d. Therefore, that's going to be a heterozygous D. So remember, we learned the Fisher race and the Wiener. That is why we did it. So we can look over here in this little row. I can tell you that this is a big D, big D. So those are homozygous Ds, homozygous Ds, homozygous Ds, heterozygous Ds, and these are all going to be D negative, and then cell 11 again becomes a homozygous D. So this is what it looks like as a panel. It covers each of the main antibody groups that are going to be significant antibodies or antigens. So we want to make sure that, that's the panels are required to have a positive for all of them. So some of the common antibodies that we see anti-D often in negative patients, which a lot of times can include an anti-big C or anti-big E with it. The number one Rh positive antibody we see is anti-big E because we see a lot of big E in Rh positive patients. And so you're going to see anti-big E a lot. It's 30% of the population has E antigen, meaning 70% doesn't have the antigen, and 30% is enough where if you get enough blood, you're likely to get exposed to it. We see anti-Kel, anti-Duffy A, anti-Kid A, and a lot of times we'll see Lewis antibodies during pregnancy. Those are those nuisance antibodies that come and go during pregnancy. So some helpful patient information when you're working on antibody ID. Age, race, and gender are always helpful. If they're older, antibodies may not be as strong. You may have some issues where it doesn't quite work out right. Gender, have they had babies? The other thing with age, pre-Korean War, we did not give D-typed matched blood. So we have a lot of people with anti-D from Korean War and before. Race sometimes help, as we talked about certain diseases, we talked, for example, about malaria, but not because of the disease. We talked about the antigens. So, whether they have the antigens or not, sometimes that's helpful. What's their diagnosis? What's going on? Leukemias affect chromosome 9. That's going to affect your ABO. There's different diagnoses that'll help us with antibody ID. Any recent transfusions, they get a couple units of O negative blood in the emergency room, and it could just make things a little messy. Prior transfusions, what is their transfusion history in the past? How many times have they been pregnant? And what is their blood type? Of course, we're going to do that anyway, but we need to know. So we start by, I give you these panels, and we're actually going to pull this up in the, I'm going to pull this up on a PDF that we can work on. But on this panel, you're going to see we've got immediate spin, AHG, and check cells. I said it's panel, screen cells. These are our screen cells. The panel screen, you're going to have screen cells, panel cells, and select cells. Those are the 3 different ones you're going to have for ID. So these are our screen cells. So you're going to see here, again, it's set up just like that panel, all the different antigens across the top. We know that this donor number here is a big R1, and these are what they're positive for. So if we look over here, you can see cell number 1 was negative, and the check cells worked. But cell number 2 and cell number 3 were positive in AHG. So that tells us, boom, I need to run a panel. So now I go to my next slide. This is the panel we're going to run. And again, I'm going to go to PDF in a minute to do some work on it. But in this panel, you're going to see we're going to run all those cells, and we just run them in AHG because that's what was positive on the screen. We do not need to go back and redo all the immediate spins. So we're going to run all those panels, and we're going to give you all these reactions. And you can see we have cells 1 through TC. TC is the same as cell 11. Usually they just pick something funky about it, like this has a couple special types to it. So TC is the same as, just use it the same as 11. And then we have a patient control. That's our 12th one. So we had some positive results. We got all this data, but data means nothing without figuring it out. So we're going to start by crossing off antigens present on non-reactive cells. We're going to use an X if it's homozygous. We're going to use a slash if it's heterozygous. And we're going to use an X when we have zygosity indeterminates. So, for example, Lewis, we don't know, Lewis is either there or not there, so we use an X. When we see S, we're going to give it an X, and we're going to use a single slash when it's a W. Anything that says NT, or if it has the slash already there that's not tested, we're not going to do any cross-offs for. So now let's open up the antibody ID, and I'm going to, you can automatically start here if you want where it's negative, but I'm going to go ahead and take us to the next one to start. So we're going to start doing this. We're going to do the first row together, and then I'm going to want you to pause the video, and we'll do some more. So first one we're looking at, see patient 1. I can't do any cross-offs on patient 1 because it's positive here. So because it's positive, I can't do the cross-offs. I have to look at my first negative non-reactive cell, because what I'm looking at is anything that is positive on this cell is not causing a reaction. Something that's positive on this cell is causing it to be positive here. But since this is negative, all the positives we don't have to worry about. So I'm going to go ahead and I'm going to start with my D. I can look here and I see our big R1, big R1. Oh, I want to make this black. Let me make this black. Okay, so big R1 here. Oh, it didn't take black. There we go. Okay. Because it's big R1, I know that I got a homozygous big D, double dose gets a double X. So then I look at my big C, little c is negative, big C is positive, it's a double dose, it gets a big X. Let me see if I can do it this way. Okay, it's gonna be faster with my mouse than my pen. Big here, over here I got little e. Big E is negative, little e is positive. There is a double dose of little e. CW is one of those heterozygous indeterminate or zygosity indeterminate, so it gets an X. My pairs here are big K, little k. There's no big K, so I give it an X. There's no KPA, but there's KPB, double dose, gets the double lines. JSA is negative, JSB is positive, double dose, gets the double lines. Duffy A is negative, Duffy B is positive, gets the double lines, gets the X. Same here, JKA is negative, JKB is positive, it gets the X. Lewis A is negative, Lewis B is positive, it gets the full X. Now, here, M and N are paired alleles, and see how they're both there? Because they're both there, they each only get one line across. They don't get the X, they get the half of an X. Single zygosity, single line. No big S, but there is a little s, it gets a 0. Lutheran B, same thing. Lutheran A isn't there, so Lutheran B gets a 0. XGA is negative, so can't do anything there. So I'll go ahead and do the second row with you, and then you can pause. Big R2, so I got a double dose of D. No big C, but I got a little c, double dose of that. Big E, I've got a double dose of because there's no little e. No CW, K is a negative, while little k is positive, so it's got a double dose. These will almost all the time, your KPB and your JSBs will almost all the time have a double dose, because if you look up and down here, they're all negative. Oh, I got a positive one there. Remember, that's one of those super rare antigens. But because it's positive over here, we won't be marking that line off anyway. So JKA has a double dose, Lewis A has a double dose. P is zygosity indeterminate, so it gets a double dose. M gets a double dose, little s gets a double dose, and Lutheran B gets a double dose, and XGA, zygosity indeterminate, gets a double dose. So go ahead, pause the video. I want you to go ahead and do the rest of the cells. Remember, we only do the negative cells. You should be doing this in pencil too, just as a reminder. This is the one time you can use pencil in the blood bank, because I cannot tell you how many lines I start that are positive and then go, shoot, that was a positive line, and have to go back and erase it. So take a pause here and then come back when you're done. Okay, I'm going to start back up. Hopefully you paused so you took the time to try it yourself. I'm going to go ahead and I've got a big C and a little c. I've got just one big E, so it gets an X. Little k gets an X. If you don't know why one of these is happening, look at the rules. I do want to point out you do have these rules. Identification of antibodies, and it goes through all of these rules here about, whoops, just these guys here about what to do and how to do this. This is in your Canvas, so it'll help you. I don't have Duffy A, but I got Duffy B. I've got JKA and no B. I've got Lewis A and no B. My P gets a double indeterminate. Look at this. M and N only get a slash, and big S and little s both just get a single slash because the pairs are all there. So then I'm going to go down here to 7. Okay, that turned out really bad. Let me fix that because I'll look at that later and be going like, what did I do? So let me go back to my drawing. Okay, so let's try that again. X. My E's only get a single because they're both there. They each have a single dose. Ah, look at that. I started on the wrong line again. Darn it. Remember I told you that would happen. This is why you use a pencil. So go back, erase those. Go back to my free draw here. So let's go back to 7. Here's the one I need. So single dose, double dose there, double dose there. Aha, here I got big K and little k. So those are going to be each a single dose. I've got my KPB, I've got my JSB, I've got my Duffy B, my Kid A, my Lewis A. I got a double dose out of an N and a double dose of a little S, Lewis B, and XGA. So then I got my last cell here to go down for. So no big C, but I got little c. So I'm going to do a mark there. I'm going to do a mark there. I've got just big K. I've got just KPB, JSB. I've got a weak Duffy B. Remember, that was only supposed to be a single based on our rule. What have I got? I got 2 kids. I got both A and B of the kids. I've got no Lewis's. I got my P there. I got M, and see, N is weak there, but because they're both there, even this, I'm going to give them both single lines through. Give the double line for the S, little s, Lutheran B, XGA. Whew. Okay, so now the next step when we go back to our PowerPoint is we are going to count the number of cross-offs in each antigen column and eliminate the antigen in it if it has at least 2 cross-offs. We use the 2 in and 2 out rule. Different places might use 3. Some places use 1. At least 1 cross-off must be homozygous in most cases. And we can include screening cells if one was negative in AHG. So we're going to go back. And what we're going to do is we're going to count. So here I've got 2 that are both homozygous. You need at least 1 homozygous. And these rules are also right here. These rules are all spelled out right there. With our exceptions for low frequency, which you will have to need to know those exceptions also. But they are all right there for us. So I've got 2 Ds. So D I can cross off. I've got 2 big C's. One of them's homozygous. I can cross it off. I got more than 2 cross-offs for little c homozygous. I can cross it off. Big E, I have only 1 and it's homozygous. So I need 1 more cell. So I'm just going to put a little 1 up there. Little e, I got 2 there that are both homozygous plus, so I can mark that off. CW is one of our low frequencies. Because of that, we only need 1 cross-off, so we can cross that off. Big K, JK is also one of our exceptions. We can rule it out based on 2 heterozygous cross-offs, but we only have 1 heterozygous cross-off, so we need 1 more heterozygous cross-off. Little k, we got 2 there, we can cross it off. KPA. KPA is one of our low frequencies. We have no cross-offs, but if the column is negative the whole way down, we can cross it off. The problem is, look at this. I got a positive cell right there, so I can't rule it out. I can't cross it off because this is positive and this is positive, and these do sometimes cause problems. So because of that, I only need 1 because of low frequency, but I need 1. So I'm going to make it mark up there. KPB, I've got more than 1, at least 1 heterozygous. JSA, see how they're negative all the way down? It's a low frequency. I cross it off. It's not causing a problem. JSB, I got several, at least 1 homozygous. I can cross it off. Duffy A, I have nothing up and down. It's not a low frequency, so I'm going to put my little 2 up there because we need 2 more of those. Duffy B, I've got a homozygous plus some, so I got 2. We're good to go. JKA, we are good to go. We've got 2 with at least 1 homozygous. JKB, I've got a homozygous and a heterozygous down here, so those are good to go. We can mark those off. Lewis A, I've got 2 right there. We can mark that off. Lewis B, I've got 1 here, but no others, so I still need 1 more Lewis B. P, I got 2 here for P, so I can mark it off. Big M, I've got a homozygous and a heterozygous, so we can mark it off. Big N, I got a homozygous plus some heterozyguses, we can mark it off. Big S, I have 1 heterozygous. So instead of just 1 up here, I don't need 1, I need a homozygous. So I'm going to make an H here. To remind myself, I have to find a homozygous cell for it, and not just anything. These ones, I can find a heterozygous and be okay. This guy needs to be a homozygous cell. I've got several for little s, including a homozygous. I can mark it off. Lutheran A is a low frequency, but you can see it's negative all the way down. Because of that, we can mark it off. Lutheran B, I got 2, and at least 1 was homozygous. I can mark it off. And XGA, I've got the 2, and I can mark it off. So right now, I've got 1 big E, 1 big K, a KPA, 2 Duffy A, a Lewis B, and a homozygous S. So let's look at ruling out. If we do not have 2 cross-off in a column, we need to indicate how many more are needed. Oh, this is what I just did. If no homozygous cross-offs, we have to indicate H. Low-frequency antigens, such as big Kel, are exceptions, which we talked about. So during these ones, as I said, only 1 cross-off is needed to rule it out. You can also rule it out if all the panel cells are negative. Do not rule out low-frequency antigens if you have an unexplained positive result. That is this guy right here. We have an unexplained positive. It was in a positive cell, so we cannot rule it out. So exceptions for Kel. Big K may be ruled out based on 2 heterozygous cross-offs. The reason is it's really, really not likely to find a little k homozygous cell. A big K homozygous cell, because little k has 99.9% of population have little k. So because of that, to find big K would be almost impossible. So big K we can rule out based on 2 heterozygous cross-offs. The Kel system does not tend to show dosage effect anyway, so we're okay there. Now, we're going to start with identifying the specificity. Oh, we got all these cross-offs. What do we do with it? So we're going to look at antigen columns with no cross-offs first. Because of that, we're going to assume that's going to be kind of where we start, and we're going to compare the pattern of positive and negative results within these columns, and we're going to select the most likely specificity based on these comparisons. We can eliminate low-frequency antigens if they've been presumptively identified. If not, we keep them in consideration. Okay, so let's go back to our point here. So the ones we have left, I'm going to grab a highlighter here because we're going to look across here. See how we have the 1E? If you want, you can make little dots of a highlighter on anything we need to find. Oh, come on. There it goes. Why isn't it letting me highlight? I hate it when it does this. Oh, I don't want it to do that. Okay, maybe this will work now. Ah, okay. Okay. So let's see if it'll let us. Oh, come on. Why won't it let me do this, guys? Okay, well, it's not gonna let me keep highlighting. So, we're in the real world, you can highlight the tops here and kind of figure out where we're looking at. But instead, what we're gonna do is we're gonna scroll up here to this guy, and we're gonna take the ones we need there and change them up there. So, for example, big E, we need one big E, we need one big K, we need one KPA, we need two Duffys because we think it's Duffy A, right? Oh, that's what I started talking about. So we think it's Duffy A because Duffy A has two that it needs. And if you follow its positive, see it's positive where it's positive here, and it's negative where it's negative there, and it follows the pattern all the way down. Now, if it doesn't follow the pattern, we might be looking at um, double antibodies, or we might be looking at something else going on, but this follows the pattern all the way down. The other thing I do want to note, the patient cells here are negative. That means we took patient cells and patient antibodies, we made the autocontrol, and then we did the check cells, and that worked. So I got 2 for Duffy, 1 for Lewis B, homozygous big S, and that is it. So now we can look at this guy and see, do any of these appear up here? Oh, yep, look at this, our homozygous S right there. We can only do it on the first cell though, because that's the cell that's negative. So I got a homozygous big S. So that means down here, I can go ahead and cross off big X. And I always like to write where I find it. Because when I go back and look at it, I'll be like, wait a minute, where did I find that from? So I was able to mark it off on the screen. So now the next step is going to be select cells. So what we have to do is test an additional cells from another panel to complete ruling out the other antigens. The selected cells can be from outdated panels. So what you do is you keep these old panels in the fridge and you go through and dig through all the paperwork till you find the right cells, and you're going to dig through the panels and find them. They can be from outdated panels or outdated screening cells. When we want to do this, the cell we pick should lack the antigen for the antibody that we have presumptively identified. So in this case, it's that Duffy, right? We think it's Duffy. So we want to make sure we find cells that are negative for Duffy and should possess one or more of the antigens that we need yet to rule out. And they should be tested exactly like the panel was tested. Okay, so we'll pop back over here. So we still need a big E, a K. I'm going to make this a little smaller for a minute because I can, oh, it's not going to let me. I thought it would let me do that. It's not going to let me. Okay, so I need a big E and a big K. So I'm going to go over here and I'm going to need a big E. I need a big K. I need a KPA. We need 2 Duffy A's, so we think it's Duffy A's. So we're going to put the 2 there. A Lewis B. Lewis B or Lewis A? Lewis B. Now, maybe it's going to let me do it now. What I like when you guys do these, you want to have your highlighters and pens handy. I want to pick a bright yellow in this case, and we are going to it's still not going to let me do it, guys. Dang it. Maybe if I start way down here. Yep, outside, let me start. I'm going to highlight the cell I think it is, because that'll help bring my mind to it. So then over here, we think it's this Duffy, so we're going to highlight this whole Duffy cell. Oh, shoot. Of course, it's not going to let me go all the way down. Okay. So we're going to highlight it because that's what we think it is. That's going to help us with our eyes. If we think it's 2 or we're kind of throwing it, that's okay too. So then I'm going to pick a secondary highlighter. I'm going to go with the pink one again. And what we want to do is we want to find a cell that is negative for Duffy, that is positive for either the E, the big K, the KPA, or the Lewis B. So here I have one that we can do for Lewis B. So that'll work. So we're going to run that cell. So I'm going to highlight that cell. Scroll down. We have another negative there, but K is positive. Oh, we do have a big E positive, so we can mark that. And we already have that. So those ones are there, so we can go ahead and we can run that cell. And then we still need to find a big K and a KPA. So nope, not there. Here's one down here. So here we have one that's negative for Duffy A, but positive for K. Still negative for KPA, but that's okay. We're going to go ahead and highlight that one. And you can see here we don't have any, actually this whole panel, this whole select cell isn't positive for KPA. That is okay in this situation because it's a low frequency. You're going to want to make a note of it on the other side. Now, one thing I do want to point out is the final step of what you need to do. What I expect you to do here is look at this panel cell because there are times that we'll have to do positive cells. I want you to tell me, I expect this to be positive. I expect this to be positive. And I expect this to be positive. Did I get the right line? Yep. So that's telling me that you're ruling these out, and we're going to assume that they're all going to be positive like we want. So what we're going to do is we're going to run this cell 17, 6, and 1. We're going to take these cells with patient plasma, and I lied. I'm sorry. We do not want these to be positive. We want them all to be negative. I don't know what I was thinking. I apologize. Go back. We want all of these cells to be negative. And when we do negatives, we do a circle with a line through it. And of course, like I'm doing this on my, when you're actually doing these on paper, it works a lot better. And then we're going to always have our check marks. Oh, that check mark turned out well. And the check marks don't always work well. There we go. Saying that, yep, they're all going to be negative and our check marks are going to work. Now, in the real lab, you actually have to put them in a tube and run them. You can't do that with these paper panels. So because of that, I want you just to tell me what you're expecting the reactions to be. So we get to the final sets. We have to, for final confirmation, and this is again on this handout, if you scroll to page 2, final confirmation right here. Okay? And then we move into multiple antibodies. Final confirmation is at least 2 antigens that are positive are going to give a positive reaction, at least 2 antigen negative cells that do not react, no unexplained positives, all reactions make sense, and the patient antigen typing is negative. So that'll be the last thing we do is we'll look for example, a Duffy A, we'll look at this patient's cell and make sure it does not have Duffy A. And you're always going to run controls with that. So going back to this. So, oops, we don't care about the software right now. Okay, going back to this, we actually were able to rule everything out except for the KPA. So going back up through here, we had at least 2 cells that are positive, that were positive, at least 2 cells that were negative, no unexplained positive. Everything here that was positive here. If this were positive and this were negative, that would be a problem. Or if this were negative and this is positive, that's a problem. That's considered a reaction that does not make sense. And that means there's still another antibody hiding out underneath there somewhere usually. And then you're going to do the antigen typing. So when you're actually at the point we've gotten this decided, I want you to come up here and on this page that'll have all the patient information, I want you to tell me it's anti-FYA. I'm writing with my computer, so your writing is going to be nicer. So we think it's anti-Duffy A, but we were not able to rule out KPA. And the reason we write this down on this sheet is because we want to make sure that if there is a problem, we know this low frequency that you're supposed to just be able to say, yep, it's not the problem. It's not causing an issue. We're all good to go. Because of that, we should be able to rule it out. But just in case, we want to make sure to make a note of it on the paperwork. I want the answer to the antibodies written on this screen page like this. I'm going to stop this video now. I will start again in a few moments with multiple antibodies, but this will get you a start on working through your homework, and you'll look at the next video next for the multiple antibodies.